Hello viewers, today we are solving some physics problems that is under Newton's laws of motion. So our first equation says that a car has forces acting on it as shown in the diagram that we have here, and the mass of the car is 1000 kg. The road is slicky, so friction force can be ignored. Part 1, what is the net force on the car? Part 2, what is the acceleration of the car? So we'll start with part 1, which is requesting us to find the net force, which is also called the resultant force. So when we say the net force, it is also known as the resultant force, because what we're getting, it is just the summation of all the forces that are acting on this car. And as you can see, all these our two forces that we have, they are acting at an angle here on this car. So therefore we're going to resolve all the forces in the x and also in the y, because all these forces that we have here, they are acting at an angle. Therefore these forces, they have the x and the y component. Okay, so to start with, we'll start with the x component here. So what we're going to do is, when you picture this our diagram, the situation that we have here, we can draw a straight line here. Okay, we can draw a straight line like this. Even here, just right here, we can also draw a straight line representing 90 degrees there. Okay, so we'll start with resolving all the forces in the x. That's what we're going to start with. So say the summation of all the forces in the x, which will be equal to what? So we'll start with this, our first force that we have here. So when you look at this, our force, the size of this force is 450 newtons here. So we're going to say the size of the force is 450 newtons. Then remember, for the x component we use cos, so say this is cos. Then the angle that you're going to pick, you're going to start from this our straight line, of which here the angle here is 0 degrees, or you can say 360 degrees, but this will take this to be our starting point, which is 0 degrees. So therefore we start from here 0. So the angle that we are going to pick, it will start from here all the way up to where? Up to that point. Okay, so meaning that if we know that all this is 90 degrees, meaning that if you are given the angle here to say is 30 degrees, you can find for the angle here that we need to use here. So what you're going to do is just say 90 minus this 30 degrees. It will give us the angle for this side, which is what? 60 degrees. So we say 60 degrees. Then we're going to say plus. Also, we'll do the same for this other force. So the angle that we're going to pick for this other force, it will start from here again, from the same 0 all the way before the same force there. Okay, so here we can see that the size of the force is 380 newtons. So we use cos, this is the x component. So the angle that we're going to use, like I said, you start from here all the way up to this point. So we know that from here up to here, this is 90 degrees. And this other portion, the angle has been given to say the angle here is 10 degrees. So therefore what we're going to do is we just say 90 degrees plus 10 degrees. That will give us the angle from here all the way up to where? Here. So the angle that we're going to use, it will be 100 degrees. So the summation of all the forces in the x, you just punch that on a calculator. So it will give me, let me punch. Okay, so this will give me 159 newtons. Then for the y component, to say the summation of all the forces in the y. So when it comes to the y, you're just changing where there is cos, you just put sine. So it will give us 450, then sine 60 degrees, then plus 380 degree 380, then sine 100 degrees there. So the force in the x, in the y here, will give us, so you just have to punch again. Okay. Sine 100. So this will give me 664 when I round it off newtons there. So meaning that the net force here, which is the same as the resultant force, it will give us for the x component, which is 159. So this is the x component, so we'll use I to represent the force for the x component. Then for the y component we use J, so we have 664 at J here. Then here we're going to say what? Newtons. So this one becomes the net force. Then now, given that we found the net force now, so moving to the second question here, which says what is the acceleration of the car. Okay, so what is the acceleration of the car? So we can see that here our net force in form of the resultant is 159I, then plus 764 at J. So 764 J what? Newtons. This is what we have. And also we have the mass of this car is 1000 kg. That's the mass of this car. So the question is asking us to find the acceleration of the car. So we know that from Newton's second law, force is equal to mass times acceleration here. Okay, so force is equal to mass times acceleration here. So we need to make the acceleration the subject of the formula. So we divide by the mass throughout. So we can see that the acceleration here will be the force over what? The mass. That's what we're going to do. So now what we just do is, since this our net force, it has the x and the y component, so we also find the acceleration for the x component, which is equal to the force for the x and also the what? The mass. So say the acceleration for the x component will be equal to the force for the x component, which is 159. Okay, that is newtons, over what? The mass, which is 1000 what? Kg. So the acceleration for the x component here will give us 159 divided by 1000 here. So this will give me 0.159, that is newtons per kg. Then also we'll do the same for the acceleration in the y. The same equation, we'll apply it in the y. So we say we have the force in the y over what? The mass. So the acceleration in the y will be equal to the force for the y, which is 764, that is newtons, over what? The mass of the car, which is 1000 kg. Then the acceleration in the y will give us 764 divided by 1000. This will give us 0.76 watt, for that is newtons per kg. So therefore the acceleration here will be equal to open 0. Then you're just adding the acceleration in the x is 0.15v, that is 9. Then you say I. Then for the y, it is 0.764, that is what? J there. Then we say what? Newtons per kg. Newtons per kg. So this one becomes the acceleration of this car. Then moving to our second question that we have. So this our question says, a Hukipaки having a mass of 0.3 kg slides on the frictionless horizontal surface of an ice rink. So two hockey sticks. strike the pack simultaneously, exiting the forces on the pack as shown. So the force number 1 has a magnitude of 5 newtons as indicated here, and it is directed at an angle of 20 degrees, that is below the x-axis here. So they are saying the force number 1 here uh, is 500 is what, 5 newtons. That's the force number 1, and it is directed at an angle of 20 degrees, that is below the x-axis, as you can see. Then the force number 2, which is right here, it has the magnitude of 80 newtons, and it is directed at an angle of 60 degrees, so that is above the x-axis. So the question says determine both the magnitude and also the direction of the Parky's what, acceleration. So we have to determine both the magnitude and also the direction of the Parky's what, acceleration. So what we're going to do first, for us to find the magnitude of the Parky's acceleration, that's what we'll start with. So we're going to start with the magnitude of the Parky's what, the Parky's yeah, we have to find the magnitude of the Parky's acceleration. Yeah, so what you do, or what we will do for us to find the magnitude, we are going to resolve all the forces in the x and also in the y. So meaning that first we need to get the resultant force. That will be the first procedure. Then after getting the resultant force, now we'll use the same resultant force now to find the what, to find the magnitude and also the direction of the acceleration to say. So we're going to say the summation of all the forces in the x. So force number 1, as you can see on our diagram here, it has the size of 8 what, newtons. Okay, I'm sorry. So force number 1 is the one which has 5 newtons, the one which is below the x-axis to say. So its size is 5 what, newtons. So remember, for the x component, we use cos. So we say cos, then the angle, we will use the angle above the x-axis. So what we are going to do, we'll pick the angle above the x-axis. So this is a situation that we have, and also here this is a situation that we have here. Okay, so in terms of the angle that we are going to use, the way we are going to pick the angle is like this. Since we are picking the angle that is above the x-axis, so that is for force number 1. We'll start right here from 0. We'll start from right here from 0. We'll move all the way up to this point before that 20 degrees. So we can see that for us to get that angle from all the way here, from this point all the way up to here, you just say 360 degrees minus this 20, meaning that you're getting the remainder. So when you say 360 degrees, okay, minus 20 to give us 340 degrees, then you say plus, then you also do the same for force number 1. So the size of force number 1 has been given, which is 8 newtons. So you say 8 what, newtons, then you say cos the angle, get the angle above the x-axis, of which this 60 degrees, it is above the x-axis, so you use 60 what, degrees. So say the force that is in the x component, for the x component, it will give me, when I punch, so 5 cos 340, then 8 cos 60 degrees, so it will give me 8.70 newtons. Then the force that is in the y, you're just changing where there's cos, you put sine, so it will be 5 newtons. Then we are going to say this is sine 340 degrees plus 8, that is newtons, then sine 60 degrees. So this will give me 5 then sine 340 degrees plus that is 8 sine 60 degrees. So this will give me that is 5.22 newtons. So now we can see that here the resultant force, which is the net force, will be 8.70 I, then plus that is 5.22 newtons. I'll use J. So J, then I'll close and open, then I'll say newtons. So now we have the resultant force. So we use the same resultant force now to get the acceleration. We know from Newton's second law of motion, force is equal to mass times what? The acceleration. That's what you need to know. So now from this point now, what we do, you know that force is equal to mass times acceleration. So we'll divide. So we're going to divide, okay, that is throughout by the mass, then even here by the mass. So we're going to see that the force that we're going to get is equal to what? It is just the acceleration, because we're looking for the acceleration. So the acceleration will be equal to the force over what? The mass. So now this will give us it will give us what now? So say, since we have the force for the x component and also for the y, we'll apply this for the x and the y component. That's what we're going to do. Okay, so say the acceleration that is in the x component to be the force in the x over what? That is over the mass. So now this one will give us what? The force is 8.70, that is newtons, over what? Then the mass of the mass of the hookey packy, it is 0.30 kg. So now this will give us so this will give us 29, that is newtons per kg. Then again we apply the same equation in the y, so it will be the force in the y over the mass. So now this will give us, so here the force in the y is 5.22, that is newtons, over the mass. So the mass is 0.3, that is kg. So this will give us 5.22 divided by 0.3. So this will give us 17.4 newtons per kg. So the acceleration here will be 29 I. We'll use I. Then for the y, 17.4 J. Then this will be meters per second squared. So this becomes the acceleration. Remember, given the acceleration now, we can get the magnitude which they are requesting us to do. So say the magnitude for the acceleration here is equal to the square root of the acceleration that is for the x component plus the acceleration that is for the y component, like that. So this will be equal to the square root of, for the x component, 29, then you square, plus for the y component, that is 17.4, then you're going to square as well. So now let's see what we get. So what I'm getting is 33.8, that is meters per second meters per second squared. So this one becomes the magnitude for the for the acceleration there. Then also we have to get the direction of the this Parky's acceleration. So to get the direction, we'll start by solving for alpha. So we say alpha is tan inverse of, that is the acceleration in the y, because we're using the acceleration, over what? The acceleration in the x. So alpha will be tan inverse of the acceleration in the y that we found. So in the y, the acceleration that we found is 17.4. Then in the x is 29. So when you punch, you're going to get 31 degrees. Then now you need to sketch so that you know where the graph is, where the angle is, by using the acceleration. Remember, our acceleration is 29i, that is plus 17.4, that would be j. So now from here, now what you're going to do is, for the x component, we have 29. You say 29 is here. Then for the y, you say 17 is somewhere there. So when you sketch, you're going to say 29, 17.4. So the point is where? There, indicating that our angle is in the first quadrant. So, and if you are looking for the angle in the first quadrant, what we are going to have is we consider theta to be the same as alpha, so theta will be 31 degrees. So this one becomes the direction. And we have come to the end of the session. Thank you so much for your time.